Makam Rosh, 29 days after the Iker.
It never goes forward?
What?
It's going almost a whole circle forward, so it
Huh?
looks like it's moving back. Like if you see a wheel that's spinning really fast, it looks like it's going backwards.
You never have a negative?
What? It's just,
You never have a negative
it's sort of like going like this. And if you have a plate,
You never positive?
you could have a, if you think about it, you can sort of picture it. Basically, the Rosh is going up. It starts going up north here. The moon is going around, and it comes back down, and then it comes back the next month. It's a little bit less the way it's going, because the inclination of these two orbits is like wobbling around. It's like a plate wobbling on a going around, wobbling on a table. And so the inclination of the moon's orbit is sort of wobbling backwards, but while the moon is moving forwards, the north-southness, the height of it is wobbling around and it's moving backwards. That's basically what it is. Simple calculation. Look at the side of the page here. Rosh, 29 days after the Iker. I wrote the Iker, copied it over there, 180, 57, 28. See it? The Rosh, 1, 32, 9. Oh, here, the way the Rambam does it makes it very easy for you. You add them the same way as you did everything, and then you subtract the whole thing from 360.
Why?
To make it negative, because it moves backwards. But the Rambam put it all together, so it's just a simple cookbook. Okay? So where do you get the Rosh? 177, 30, 23. That's called Makam Rosh. Where is the Makam Zonov, if the Rosh is there? Hello? Where's the Makam Zonov?
Stack up.
Huh?
180 around.
Stack up.
180 around. Yeah, like minus 3.
Why?
Here's 177. So 180 subtracted or added to that is just the opposite around, which is the same as 357, whatever it is. Okay, anyway, next page. Page 14.
It makes it negative the way you do it in binary.
Huh?
It makes it negative the same way you do it in binary.
Right, well that's what he does. As a matter of fact, since you're a computer programmer, you can see that the way that Rambam is doing this, especially if you read inside, he's literally writing a program. If this is this, then do this. If this is this, then do this. Here's a table of values, plug them in. It's literally like the same kind of thought process that you have in writing a computer program, which is very odd because that was 850 years ago when nobody had even thought about this kind of thing. Okay, meanwhile, so now here's a picture on page 14 of illustrating the Rosh and the Zonav. The moon is going from Zonav to Rosh. Therefore, the moon is south of the sun's orbit. Oh, all right. Now, take a look at the Rosh and the Zonav. I think that's the Lashon of the Rambam. Now, let's consider the Rosh and the Zonav. Where is the Rosh? It's at 177, right? Where is the Zonav? 357. Everybody understand that?
Yeah.
Okay, easy to calculate. Where was our moon? The moon itself was at 48, right? So, where is that compared to these two things? Is it between the Rosh and the Zonav? Is it before the Rosh or is it before the
He's
Zonav?
on the day of the Iker.
Huh? What?
On
No,
the
this
day
is
of the
29 days. Where is it? Huh?
But what are we trying to do right now?
I want to find where is the moon compared to the Rosh and the Zonav. That's what this picture is. The Rosh is at 177. That's almost 180. See, it's over to the left there in the picture. The Zonav is almost at 0, right? The moon is up here.
48, yeah.
Huh?
48.
Up at 48.
It's under the sun.
All right. So what this means is the Rosh is what happens when the moon goes north, right? It's where it crosses going north. The Zonav is where it crosses going south. Since it just passed, it's after the Zonav. So that means the moon is south of the sun's orbit. You got it?
Yeah.
All right. Now, we're going to talk about what the Reichav is. The Reichav is what's called latitude. You know, latitude is the measurement of north and southness in degrees. This is latitude not from the equator, but from this ecliptic, from the sun's path. Rambam gives you, again, the same kind of thing you use for figuring out. There's a table of masluls and a table of manas masluls on page 14 here. What we're going to do is figure out how far north or south of the sun's orbit is the moon. We already know it's south because we just figured that out using our logical idea that the moon is in front of the Zonav going towards the Rosh, so it's south. How far south is it? Perek Tezayin Halacha Yotes tells you how you do it. You take the Areach, okay? I should give these steps over here for the Rechav. This is also the same kind of thing. All right, this is step 10. Calculate Rosh and Zona. Okay? Which we know how to do. It's the same kind of business we've been doing the whole time. Simple stuff. Add the things together, you get it. Then, is it north or south? If it's between, if the Yereach is it the Yereach? Is it north or south? If it's between the Zonav going towards the Rosh itself, if it's between the Rosh going towards the Zonav, it's north. Right? This is calculate. Yeah, I'm sorry, I can't write here. Calculate the Rosh and the Zonav. Okay, we know how to do that from the instructions on the previous page, which is page 13. Is the Yereach north or south? Use this little picture, think about it for a few minutes, and then you know it, right? Now, next thing you do is subtract.
Why do we need another latitude?
Because the latitude will also determine, the latitude and the longitude differences will determine how far away the moon is from the sun at the time that you want to see it. We're trying to figure out if it's visible or not. If it's really far away in latitude, but not so far away in longitude, those two things might add together a certain way to make it more visible. If it's south of the sun, and we're way up north looking at it.
What Manasamasal is.
What?
I thought that's what Manasamasal is, the difference between the moon and the sun. No?
The merchak is the difference between the moon and the sun in longitude. Or it might be the opposite way. It might be latitudinally going north, which brings it closer to the sun from our point of view. Even though the longitude line might be moving like this, so the difference might be like that, but in latitude, it might be moved off like this or something. So these two things combine in a very complicated way, which the Rambam describes in Perek Zayin, and those are the conditions for deciding if it's visible or not. So you need to know the latitude as well. The latitude, again, is not latitude like on Earth. Earth's latitude is measured from the equator. In astronomy, that's called declination. It's not called latitude. Latitude in astronomy is from the ecliptic, from the sun's orbit that we've been talking about.
Same as Rama.
Huh?
Like the Rama.
That's what it is. That's what we're talking about.
No, I'm
So
saying,
the Rambam gets
in
it.
astronomy, they do it the same way. They're also measured from the ecliptic.
That's where the Rambam got it from. He got it from astronomy.
No. I mean, it depends what you're talking about. It's if you're talking about Earth latitude, then it's Earth latitude. The Rambam talks about that also. He mentions that Yerushalayim is like 34 degrees or 32 degrees, something like that. And then he mentions the latitude there, where all these numbers are valid. What range of latitudes and longitudes is range? That's Earth latitude. But all this stuff now, Rechav has to do with differences from the Earth, from the Moon to the Sun's orbit. Let's quickly go through this. Next step: subtract. Moon. This is Makam Amiti minus Rosh. Okay? I don't know. I got
You can always go after, let's say they're on line.
Huh?
Yeah.
Alright.
Calls back to the line.
Right, you guys have to go to for bringing now anyway, right?
Right.
Alright.
What happens to the 3?
Okay. Meanwhile, alright, so somebody be in touch with me if we're going to do this. We're going to pick up again after this Kislev. This Hanukkah is coming up, and I don't know. Anyway, if there's any extra things of sheets, give them to me so that I can have them for next time. All right, so meanwhile,
Mendel, what's your favorite thing about Awela? Oh, maybe we shouldn't play with this. What's your favorite thing about Awela?